Welcome back to Reset, the podcast where we ask better questions about health because the body's not broken, it's adapting. I'm Dr. Catie Harris, and today we're going to tackle the very first question in our Reset framework, which is, can you build healthy cell membranes? Now, I know that probably doesn't sound like the most exciting place to start, but if I told you we were going to talk about Alzheimer's and hormones and peptides and weight loss or longevity, you'd probably understand why it matters. Cell membranes, most of us haven't thought about them since biology class, if you even took a biology class. And even then, we probably learned that the membrane was basically this little line somebody drew around the outside of a cell. But I want to convince you today that this structure we've largely ignored is one of the most important pieces of biology in your entire body. Because before a hormone can send a message or a nerve cell can communicate, before nutrients can move appropriately into and out of a cell, and before many of the processes that we associate with health can happen efficiently, we need healthy cellular infrastructure. And a huge part of that infrastructure is the membrane. So let me give you an analogy. Imagine building a beautiful house. You've hired the best architect, you have an incredible construction crew, and everybody knows exactly what they're doing. But the materials that are delivered to the job site are crap. They're terrible, right? The wood is warped, the windows leak, the electrical components are unreliable, the plumbing is damaged, the insulation is poor. Well, your workers can still build something and they're going to do the best they can with what you've given them. But sooner or later, you're going to begin noticing problems. Maybe the electrical system starts acting up. Maybe the plumbing's leaking. Maybe the house can't hold heat, and maybe the doors don't close correctly. And eventually we start naming all of these individual problems. But the deeper question is, what was the house built from? And that's how I want you to start thinking about your cells. Your body is constantly rebuilding itself, and it needs the raw materials to do that. So your cells are not static objects that were built when you were born and somehow have to last your entire life. They're dynamic. Their proteins are turning over, lipids are being replaced, structures are being remodeled, and damage is constantly being repaired. So the membrane is part of that continuous process. So the first reset question isn't really about membranes. It's about something bigger. Does your body have the resources it needs to build itself well? And that's where I want to start. So every human cell is surrounded by a plasma membrane. And I don't want you picturing a rigid wall. Human cells don't have cell walls the way plants do and bacteria. A wall is designed to be rigid and structural. A membrane is different. It's flexible, dynamic, it bends, it reorganizes. There's movement within it. Proteins and lipids, they move within it. Receptors cluster and separate, and parts of the membrane can curve inward, they can pinch off, they can fuse with other membranes, and constantly respond to what's happening around the cell. So instead of imagining a plastic wrap around a cell, imagine a living border that is continuously sensing and responding to the environment. So that's much closer to what's actually happening. And this distinction matters because the membrane isn't simply keeping everything inside. It's actually regulating the conversation between the cell and everything around it. And remember, we said there's 44 trillion cells. So think about how many messages your cell receives every second. So insulin is circulating, hormones are circulating, your immune molecules are circulating, nutrients are available, oxygen availability changes, glucose is changing, fatty acids are changing. So the nervous system is sending signals and other cells are sending signals as well. Some molecules interact with receptors at the membrane, so others cross the membrane and interact with receptors inside the cell. So different signaling systems use different pathways. But the larger point is that the membrane is critical to how a cell interacts with its environment. It's part of the communication infrastructure. And that's why membrane health has consequences far beyond keeping the contents of the cell together. So let's use insulin because almost everyone has heard of insulin resistance, right? So insulin circulates through the bloodstream, and it binds to receptors located on the cell membrane. And that binding initiates a cascade of signaling inside of the cell. So when we talk about insulin resistance, we're not talking about insulin is banging on a solid wall trying to get through the glucose through. We're talking about a communication problem. A message is being sent, the receptor receives it, and then the cell has to respond to that message. So think about what that means. The membrane isn't just a fence, it's more like a communications department at a very busy company. Messages are arriving all day, and some signals need to trigger immediate action. Some substances need transport proteins, and some things should be allowed in, and other things need to be just kept out. And also waste. The cell makes waste, so that needs to leave. Ion concentrations have to be tightly controlled. And all of this has to happen without you consciously managing any of it. So I use the international airport as an analogy sometimes. So imagine the membrane is a highly sophisticated airport boundary. Now, not everything simply walks onto the runway. There's gates, there's security systems, there's transport mechanisms, credentials, different entry points for different things. Some molecules can cross relatively easily, right? While others require channels or transporters. Others have to interact with the receptor and never physically enter the cell at all. The point is the membrane helps create order, and biology needs that order. Now, the next question that we ask is, well, what is this membrane actually made of? And that's where the story gets really interesting. The membrane contains a lipid bilayer, and it's largely built from phospholipids and cholesterol, proteins, glycolipids, and specialized molecules. So those proteins include receptors, transporters, channels, enzymes, and structural proteins. So when you look at a membrane, you're not looking at one substance, you're looking at an entire ecosystem. And one group of molecules I've become particularly interested in over the years is plasmalogens. So I remember learning that phospholipids early in my career, but plasmalogens were never discussed. And even today, if you ask that, if you take a handful of any providers, even the biggest names in the industry, and you say plasmalogens, they'll have no idea what you're talking about. Yet, they're an important class of ether phospholipids found in the cellular membranes, and they're particularly abundant in tissues such as the brain and the heart. So they appear to have important structural and signaling roles, and they're also interesting because of the way their chemistry interacts with the oxidative processes. And this matters to me because the brain is extraordinarily dependent on membrane biology. Neurons have massive amounts of membranes. So every axon, dendrite, and synapse depends on membranes being organized appropriately. And if you've been listening to Reset from the beginning, you'll already recognize where I'm going with this. We're not talking about one isolated molecule causing one isolated disease. We're talking about an infrastructure. If I want neurons to communicate well, I need to care about what those neurons are built from. If you want mitochondria to function well, the mitochondria themselves have membranes. They actually have a double wall membrane. So if I want membranes to behave appropriately, I need to care about the membrane environment that those receptors live in. And that's why systems biology becomes very important. Everything connects to something else. Now, I want you to picture a canoe. Imagine you're trying to paddle through some normal water. The paddle moves, the boat responds, everything works. That's, no problem. Now, imagine trying to paddle through molasses. So you have the same canoe, the same person, the same paddle, but a completely different environment. And that's one way to think about membrane fluidity. So membranes need an appropriate degree of fluidity and organization. They can't simply be as rigid as possible, and they can't be as fluid as possible. Like so much of biology, the goal is balance. So the lipid composition of the membrane influences its physical properties. And that affects the behavior of the proteins that are embedded in it. So again, we're back to communication. The receptor matters, but also the environment that the receptor is sitting in. That's why I think nutrition discussions become too simplistic. We often say, well, what's the best diet? I think a more useful question is, what raw materials does your body need? And are you actually getting them? Because fats, amino acids, vitamins, and minerals we consume don't just disappear after digestion. They're substrates, they're building materials, and they're incorporated into biology. And so the body is constantly deciding what to do with what we've given it. One of the central ideas behind reset is that the body is doing the best it can with the resources available in the terrain it's living in. We may not always like the workaround the body chooses, but if we want a different outcome, we have to ask whether we've changed the conditions. And that does bring us to diet. I hear people say all the time, well, we should be able to get everything we need from food. And ideally, food should be absolutely the foundation. I'm not interested in replacing a healthy diet with bottles of supplement, but I also think we have to be realistic because people eat very different diets. Absorption differs in everybody. Digestion function differs. Age changes nutritional requirements. Medications affect nutrient status. Chronic illnesses change demand. Right? A person with autism has a much, much higher demand for B vitamins. Someone under significant oxidative or inflammatory stress is going to have very different requirements from someone who's 25, sleeping 8 hours a day and exercising and eats an excellent diet. So rather than arguing philosophically about whether supplements are good or bad, I prefer a more practical question, which is, does your biology have what it requires? That's the question. Sometimes the answer comes primarily from food, and sometimes targeted supplements make sense. Sometimes the real issue isn't intake at all. It could be digestion, absorption, metabolism, inflammation, or another part of the system. So that's why we investigate instead of guessing. Now, one area I want to talk about carefully is dietary fats, because there's a lot of noise around this subject. You'll hear people say that certain fats are poison or that they're the type of fat doesn't matter at all. And biology is rarely that simple because different fatty acids influence membrane composition and the oxidative state of fats matters too. So what I care about clinically is whether the person is providing appropriate building materials while minimizing excessive oxidative stress. So I'm much less interested in creating a villain than I am in understanding the biology. And that's something you're going to hear repeatedly on this podcast. I don't need a villain. I need an explanation. So if a membrane is being damaged more quickly than it can be replaced, I want to know why. Is the oxidative stress excessive? Is inflammation chronically activated? Are the necessary lipid substrates available? Are antioxidant systems adequate? Is the mitochondrial dysfunction adding to that problem? Is metabolic health poor? Those questions move us forward. Saying one food caused everything usually doesn't. Now let's connect membranes back to symptoms because otherwise this can start feeling very theoretical. Someone comes in with brain fog. Another person has insulin resistance. Another has chronic inflammation. Another has hormone symptoms. Another is worried about cognitive decline. These conditions are not all caused by unhealthy cell membranes. And so I want to be clear about that. But membrane biology participates in the systems underlying all of them. That's why I call it foundational. So think about a city. The roads aren't the entire city, but if the roads stop working, almost every other system is going to be affected. Deliveries become difficult, emergency services slow down, people just can't get to where they're going, and businesses will start to struggle. The roads didn't cause every individual problem, but the infrastructure affects everything. So that's how I want you to think about membranes. They are infrastructure. When I evaluate someone through the reset framework, I want to know whether that infrastructure has what it needs. And practically, what does that look like? It starts with the fundamentals: adequate protein, adequate dietary fats, choline and other nutrients involved in phospho-metabolism, cholesterol, very important, one of the most important lipids in the body, micronutrients required for normal cellular processes, And then I look at what's potentially damaging the system: oxidative stress, chronic inflammation, poor metabolic health, smoking, heavy alcohol exposure, poor sleep, a sedentary lifestyle. All of those can influence the cellular terrain. And notice what I'm not doing. I'm not saying, here's the cell membrane supplement, everyone take it. That's not reset. Our goal isn't to micromanage the cell. The cell already knows how to build the membrane. It's been doing it your entire life. Our job is to ask whether it has the materials environment necessary to do that job well. And in my practice, one of the tools that I use in selected patients is the targeted membrane support, including products designed to provide specific phospholipids or plasmalogen precursors. So I tend to think of these things, particularly in patients where brain health, accelerated aging, or membrane biology is part of the larger picture. But I never want the takeaway to be that one product fixes the membrane, because that's not how biology works. The supplement is a tool. The biology is the system. And the system also depends on sleep, nutrition, metabolic health, movement, hormones, inflammation, mitochondrial function, and everything else that we're going to discuss throughout Reset. That's why I wanted membranes to be question number one. Not because membranes are more important than everything else, but because they make up the entire framework easier to understand. The body is built from cells. Those cells are constantly rebuilding themselves. They need raw materials, they need energy, they need information, and they need an appropriate environment. And when those conditions aren't ideal, the cells adapt. That's the reset philosophy in one biological structure. So here's today's question. Can you build healthy membranes? And I don't want you to answer that question by looking at your supplement cabinet. I want you to think more broadly. What are you giving your body to build with? What is damaging those structures faster than you can repair them? How is your metabolic health? How is your sleep? How much inflammatory stress are you carrying? Are you eating enough of the nutrients that your body requires? And if you're experiencing symptoms, are those symptoms telling you something about the environment your cells are trying to function in? That's the deeper reset question, because we don't want to spend our lives telling the body how to do its job or taking 100 different supplements. We want to create an environment where it can do its job. And next time we're going to take this one step further, because we're building the structure isn't enough. The cell has to power everything it does too. So our next reset question is, can your mitochondria make enough energy? And we're going to talk about ATP, metabolic flexibility, mitochondrial signaling, fatigue recovery, and something I think is incredibly important, why the body sometimes deliberately chooses conservation over performance when energy becomes scarce. So until then, remember, your body isn't broken. It's adapting. So keep asking better questions, because better questions lead to better biology. I'm Dr. Catie Harris, and this is Reset. If you've enjoyed today's episode, subscribe whenever you listen to podcasts, leave a review, and visit the Reset Method at phillywellnesscenter.com for more resources, education, and tools to help you understand your biology. Until next time, your body isn't broken, it's adapting. Keep asking better questions. I'm Dr. Catie Harris, and this is Reset.